Hi, we are Team Zinx Flex. First of all, our research topic is development of high sensitivity, multifunctional piezoelectric sensor for flexible devices based on carbon nanotube and zinc oxide nanoparticles. Our contents are divided into 4 parts. First, introduction. Second, experimental method. Third, expected results. And last, conclusion. First, introduction. The energy depletion of fossil fuels has long been an issue. All of that resources are limited. So, there have been various studies about renewable energy. However, there are also limits to them. For example, we cannot harvest solar energy on a rainy day. We can harvest wind energy only in the coastal areas. Therefore, we became interested in other sources of energy harvesting. Among them, we chose piezoelectric energy because it can convert into various energies.
Hi, I am Jiwon. I will talk about principle of piezoelectric effect. It is mechanism which can generate voltage or electric current by applying force to an object. As you can see diagram in the mirror, when you apply force to the object, it creates voltage. On the other hand, when you apply the voltage to the object, it creates force or movement. Next, market size. As you can see in the graph, research about piezoelectric materials and energy harvesting have been increasing exponentially. So we will make piezoelectric sensor. It will be high sensitive and multifunctional at the same time. Also, we will make flexible device to obtain piezoelectric energy effectively using CNT and zinc oxide nanoparticles.
Next, I'm going to tell you about experimental method. First, we chose zinc oxide as a material for our research. The crystal of zinc oxide has a root-shaped structure. It is a hexagonal system as shown in this figure. If you apply force up and down to make a voltage, the pink dot will go down and the white dot will go up. Because of the white dot positive, the upper will be positive, and because of the pink dot negative, the lower will be negative. And when we release our force, it will be opposite. Our lab has researched zinc oxide continuously, so you guys will be curious about the difference between now and before. The biggest difference is that we are using zinc oxide with nanoparticles. It is suitable for flexible device and it is highly efficient because of high surface to volume ratio and also it is easy to use. Now there is a mechanism of zinc oxide and CNT. We mix zinc oxide with CNT. It is one of the key points of our device. CNT can make a nanoelectrical bridge among zinc oxide nanoparticles. This is the reason why we use CNT. In other words, CNT can make it easy to move energy to upper and lower electrodes while hopping. You can also see in the graph below, the voltage is best when we add CNT into zinc oxide.
Hi, I'm Jiwan. First of all, we decide to make a layer mixing zinc oxide, CNT with PDMS. The core of our device is flexibility, so we chose PDMS, known as typically flexible materials. In addition, silver paste and carbon fiber were used for post-processing and we intend to make electrodes with top-up structure. Next, I will explain about substrate procedure. So, first, mix PDMS with curing agent in a ratio of 10:1. After stirring, pour the solution in Petri dish. Then we use desiccator for air stripping. Finally, cure them in an oven of 85 degrees Celsius for about 20 minutes. Next, we mix zinc oxide CNT with PDMS to put them on the substrate. First, add IPA until CNT sinks and put them on sonicator for about 30 minutes at room temperature. And then it makes CNT dispersion better. During dispersion, heat PDMS on hot plate of 120 degrees Celsius to reduce the viscosity for about 30 minutes. 20 minutes. And then we put zinc oxide nanoparticles, CNT and IPA into heated PDMS. And then we stir with magnetic stirrer for mixing the solution and evaporating IPA for an hour. Next, cool down the solution for 5 minutes up to 30 degrees. The subsequent process is same as PDMS curing procedure except spin coating method.
Hi, I'm Jigyong. I'm gonna tell you about expected result. First, test mechanism. We measure signals using lab film through DAQ device. But there must be some noise. So we are gonna remove this using lab programming or circuits. As I told you before, we are gonna make a voltage per second graph like this. We plan to measure regularly with Arduino, controlling anchor of submotor. Also, we'll build IV curve through multimeter and power supply. It will be automated by lab view. In addition, we will produce many kinds of data about electric signals. Our goal is as follows. Minimum voltage to 100 millivolt, maximum voltage to 500 millivolt, and resistance ratio to 60%. It is just our goal. We will always try hard to make the best result. And last, we will make the prototype by Arduino and LabVIEW. With using them, we can make many kinds of instruments like drum, pump games, launch pad, shooting games, and so on.
Finally, I would like to talk about our team's conclusion. Our final goal is to make a piezoelectric sensor that can make a way to energy harvesting. When we make a device which can harvest energy, this can save energy in daily life. Our schedule is as follows. This is our team member. I'm Kwang-soo, I'm team leader, and our team member is Jigyong, Jiwon, and Jiwon. Our roles were divided into followings. Thank you for listening to Team Zinx Flex's presentation.